right, so it looks like it's 3 o'clock, so I'm gonna go ahead and get started. Again, if you wanna follow along, follow, for Windows, you can use Windows for subsystem for Linux. For Mac, you can use the terminal, and for Linux, you should know how to do that already. If you have any questions, just throw them in the chat. But if not, we will get started. Introduction to the Linux command line, the beginner's guide to using a shell. Just for content, first slide is just how to follow along. Then we'll go into the basic commands, just the commands that everyone should know about. Then we'll go into what's called data wrangling. We'll get to in a bit. Then we'll go into security. And finally, we go into questions. And it looks like it's glitched out. Let me go ahead and, all right, well, let's get started. Again, like I have said a couple of times, most of the commands that we're going to be running today are applicable across all Unix or Linux machines. So if you want to get started and just try out a couple of these commands, for Windows, you just use Windows Subsystem for Linux. That's very easy to install. So just a quick introduction about me. Who am I? I am currently a senior here at UCF, and I'm studying computer science. My job, my role is a software engineer. So I'm a developer. I code, I make programs, I make games, and things like that. Out of all of my interests, one of the biggest ones is actually cybersecurity. So because of that, I actually joined the UCF National Collegiate Cyber Defense Competition, and we actually got first place nationally. Beat out a couple of really cool teams. That's actually me right there in the middle. So I know a little bit about cybersecurity in general, considering we won the national competition. Primarily, I was doing Linux system administration, so that's what I'm here to show you. So basic commands. All right. So first, what is a command? Right? Well, how do you know that it's a command? Well, command is just made up of 3 components. First, the program name, then the argument, and finally the flags. Usually the order is the program name, and then the arguments and the flags, it depends on the program, but usually it's the arguments and then the flags. So program name is just the name of the program. For example, who am I is actually a program name. Let's show you that. I'll go ahead and actually show you that. So here I'm going to go ahead and pull up the terminal. Please let me know if you're able to read this, or if you want me to make it bigger or smaller. Beautiful. So who am I? Basically just tells you the user that you're currently logged into. But that's just a very simple command. You just write that into your terminal, and it just pops out an output. Arguments. They are tokens separated by white space. Usually they're used to give extra information to the program. So for example, the program diff, if you just run diff by itself, is saying missing operand after diff, because diff requires 2 arguments, one for one file and one for another. And it basically just looks at the difference between 2 files. But you can see that how it might be useful for a program to have arguments. So for example, file 1 and file 2. Now, file 1 and file 2 don't exist, but that's how you would use that program. And finally, we have flags. They're used to modify the behavior of a program. So usually they use 1 dash or 2 dashes. And here's an example. I have ls and then -a. So if I just run ls, it shows that. If I write ls-l, for example, it actually shows more stuff. And we'll get into what -l basically means. But basically, it changed how the program actually runs. So first things first, how do you actually navigate through the shell? So there's a bunch of commands that you can use to navigate. If you are used to Windows, for example, This is very similar to going to your Explorer and going through files and folders. For everything that you do, for example, creating a file, deleting a file, moving around, there is an equivalent command on Linux. And here's some of the very common ones. PWD stands for print working directory. Basically, it tells you where you are right now, which directory you are right now. LS basically lists the contents in the current directory that you are in. And we saw that before. CD, you're able to actually change directories. So basically opening up a folder and closing it, same thing. MKDIR, make directory, self-explanatory, just makes a directory. CP basically copies a file or directory. MV, very similar. You can move a file or a directory, and RM removes the file or directory. So, well, actually, I'll go ahead and show that off. So, first thing I'm going to do is PWD, so I can show you where I am at in the command. So right now I am in users, my name, folder developer, folder projects, folder battleship. That is where we are at right now. Another thing, this is known as a absolute path. Basically, this is where the path is not in relation to where you currently are. If we were to change directory, for example, if we wanted to go into the projects folder, we could copy this, right? We could copy this and do CD for change directory, space that, and we'll move into that project. And if we do ls, which is list all the things in this directory, you can see that there is different things because it's a different directory. And if we do pwd, then you'll see that we're currently in a different directory. Now, that seems really tedious, having to copy and paste direct like paths. Luckily, there's a thing called an absolute path or a relative path. Basically, it is the path in relation to where you are currently at. So let's go back to the battleship folder. Again, we are in the battleship. Go ahead and move this like that. Battleship folder. If you wanted to go back if you wanted to go to the projects, instead of doing what we originally did, you can do CD for change directory, and then you can do 2 dots. 2 dots indicates the folder above you or your parent folder. If we do that and we do PWD now, as you can see, now we are in the projects folder. And with that, you can do a bunch of different things. I won't get too deep into it, but that is how you navigate through the shell. Right? If I wanted to, for example, you see the scores.txt. If I wanted to delete that file, I can do rm for remove, and then scores.txt. And then, bam, if we do ls again, you can see that scores.txt is not there anymore. Right? Now, I just said a bunch of different commands. How do you actually know what the commands do, right? Other than just knowing that they exist? Well, there's a bunch of ways that you can know how a command works. The most simple one, the one that I recommend, is doing --help. So let's go back to here. What were we doing? We're doing ls. If you do ls --help, illegal option, cool. Let's do git --help, which I know exists. It's kind of hard to see because of how big this is. Let's go ahead and zoom out a little bit. But here, you can actually see all the different things that you can do with git, but the command git. For example, clone, init. Yep, that is a lot of text. Yeah, and the more complicated the command is, the more complicated the output is. Let's see a more simple one, maybe grep. That's also very complicated. But yeah, In general, you can do dash dash help to know uh, the different things that you can use a command for. Now, when that is not helpful, for example, with grep, there's another command that you can use called man. Man is a manual. Basically, most commands have a manual associated with them. So if you do man space grep, here you can see a huge manual for how to use grep, right? And it gives you a description, the grep utility, blah, 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 blah. And if you wanted to know, for example, uh, let's use one that we have already used, for example, ls. It tells you ls list directory contents. And if we scroll down to, say, -a, it tells you it includes directory entries whose names begin with a dot, right? And here, that's really easy. That's how you know what the different arguments are for, or the different flags, depending on what you're looking for. And finally, I mean, we're developers, we know this. Google. If you don't know a command, feel free to Google it. Might be difficult to Google a specific command, but in general, Google is your friend. um, yeah. And this is really important. Knowing what a command actually does. Do not just randomly copy and paste commands, please. This command right here, it's a really common prank that people do. Basically, just deletes every single file and folder on your computer. Um, and they're usually given to like um, yes, and yeah, I don't use Chrome. Um, Basically, it's given to like newbies that don't know enough, and it just deletes everything. Don't be a newbie. Know what you're running. Finally, we'll talk a little bit about environment variables and path. So, definition of an environment variable is a set of dynamic named values stored within the system that are used by applications launched in shells or subshells. What does that mean? Um, Basically, is a thing that associates one word with another. It's like a dictionary. Um, there's a bunch of different environment variables. You can actually print them out. If you do print env, you can see, for example, here the Java home director environment variable is associated with this string right here. And this is used for a bunch of different things. But one very special environment variable is the path environment variable. Basically, this tells the shell where a program actually is on your system. So we can actually see what the path actually is. So if we do echo $path to show us the path, here for my computer, it is a lot of different folders, but you can see one really important one is this one, for example. User Nelson Torres genv bin. Basically, that folder, if we go to it, is going to have the program that we're able to run. So this is how your shell actually knows where, for example, grep is. So for example, if I ran the command ship, it doesn't exist. The shell knows that's not a command. However, if we were to, for example, if I show you right here, I actually do have a ship program right here. Basically, it's just a battleship program that I have on my computer. But let's say we wanted to actually be able to run the command ship from anywhere. There's actually a command for that. You basically just edit the path environment variable to do that. So let me just pull it up. Give me 1 second. I don't know it off the top of my head, but it's something like export path equals $path, and then pwd this. Right, I believe so. And what does this do? Well, basically, export is setting up a environment variable. That is what that does. is setting the path environment variable equal to what it was before, but then at the end of it, it adds the pwd command. And if we know pwd is where we currently are, so exporting that actually adds that full this at the end of path. Therefore, if we were to now run ship, oh, look at that, welcome to battleship. And you can run this from anywhere. So for example, if I go back to my, if I just go back one, right? It just knows that ship is where the battleship command is. And this is really useful. For example, if you were to install Flutter on your computer, Flutter actually tells you to do this. This is what it tells you right here. And that's actually a problem because either a lot of developers just don't know what this does, right? So they're just randomly copying commands. And in fact, this command that I just ran is not even the best command to run, because if I were to close this terminal and reopen it, ship is not going to be a thing anymore, because of how that command works. Basically, you have to run that command before every time you open the command line. And the way you would do that, they actually do have a way they show you how to do that, but it's important for you to know like how that actually works, because you might be struggling like, hey, it worked yesterday, but now that I closed my computer and reopened it, or my command line, it doesn't work anymore. Why is that? Sure. Very simple but very effective command. I'll actually go ahead, and I just realized I don't have the commands available for you guys, but I'll go ahead and drop that command into the chat if you want to run it for yourself. Basically, you want to go into a path that has a like a program, so chip, for example, and then just paste that in there, and then you should be able to run that from anywhere. Data wrangling, right? So what is data wrangling? Basically is a way to convert data from one format into another. Us as developers, this is like very common. We do this all the time. You have a class and you use that class to make another class. And Linux actually has a bunch of commands for data wrangling. This is just a couple of them, but grep, very common, very popular one, basically searches any given input files by selecting each line that matches one or more patterns. So for example, if you just have a big text file and you want to search for a specific, or for how many lines have a specific word in it, well, you can do that really easy using grep. Yeah, unique is another command. Basically, it reports or filters out repeated lines in a file. And in a bit, we'll actually show how all of these can be used combined to basically convert one set of data into another set of data. But yeah, sort is another command. Basically, it sorts records. Very self-explanatory. Again, if you have any questions about these, you can always either Google it or use the man page or do --help, like previously mentioned. Sed is a stream editor. That one's a little bit more complicated. Same thing with awk, but it's very similar to grep. I won't get into any specifics, but these are very powerful tools that you can use for data wrangling. So yeah, and other than that, so how would you actually data wrangle? Like, how do you actually do this? Well, Linux actually has a very powerful way to combine different programs together. So these two ways are piping and redirecting. So a way to connect the two programs together is piping and redirecting. Usually what you would do is the output of a program, you redirect it into another program. So redirecting, right? Used to pass output to a file. So for example, if you run any command, for example, ls to know what files are in here. If you wanted to move that into a file, like this output right here, put it into a file, well, it's really easy. Um, Here you have the ways that you can do it. Um, this one is the one that we want. It redirects to a file, so the little greater than symbol. Um, Basically, as you can see in the example, there is the command followed by the greater than symbol, followed by the name of the file. And here I'll actually go ahead and show you that. So um, this is the command that I'm going to run to and save to a file. So this is the expected output. If we do the same command followed by a greater than symbol, followed by um, file, maybe not file, output. All right. And if we do ls again, you can see that there's now a file called output. And if we were to look into the contents of output, well, look at that. It's the same thing that we just saw, right? Except now it actually has the output file. But yeah. Yep. And this is very powerful. Um, because you can combine, you can grab one output of one program and connect it to the other. So for example, we were previously talking about WC, which is word count. If we do dash dash help, sorry, we do man WC, it tells you the numbers of lines in a file or any text. So if I were to, for example, do ls tag l, right, that gives you these 5 lines. If I wanted to count the amount of lines, I can pipe using this symbol. So this output is now going to be the input of this next command. And for this case, I'm just going to do wc tag l, which is basically going to count the amount of lines. And as you can see here, there's 1, 2, 3, 4, 5. So there's 5 lines. And this is actually it's really powerful. I'll go ahead and show you on the next slide. Parsing logs. If you don't know what logs are, basically is a detailed list of an application information, system performance, or user activities. Basically, any application while it's running is creating logs so you can look back at the history of the application. And it's really cool, right? I have here, if I go to here and I ls, here I have a list of a lot of logs. This is actually a Minecraft server, and this has logs for basically every single day of a Minecraft server running. So if I, for example, wanted to look at any random one, let's look at the first one actually. What's the name of it? 0929. Right? And basically, since they didn't accept the EULA, EULA, it gives you this error. But this is really good because what you can do with this is look at what has happened in the past. Now, I want to know who has been logging into my server. More specifically, not just who, but who's logging in the most. So this is actually really simple to do using data wrangling. So here I actually have the steps, but I'll just go through the thought process myself. So here I have a bunch of different log files, right? I know that every time someone joins in the log files, there is a message saying blank joined the game or something like that. So what I can do is I can use grep basically to get every single line that has the word joined in it. So if I do joined, grep joined followed by a star. So for every single file, look for every instance of the word joined and get every single one of those lines. You do that, bam, we just get a list here of the people that have joined, right? So here you can see just a list of people that have joined. These are just the people that have been playing recently. But yeah, um, so now that we have this, what do we want to do? We want to some way be able to count the amount of times each individual person has joined. Um, so one of the ways that we're going to do this is just sorting, or sorry, counting the amount of times that each person has appeared. Now, this is a little bit complicated, but if you get the output of this and you run it through sed, we can actually delete this whole thing because we don't actually care about the time or this is always the same thing. We don't care about the time. So we actually just want to delete the beginning of this. Now I already went ahead and counted how many characters there are. There's about 50, or there are 50. So what I'm gonna do is I'm going to remove the first 50 characters. Um, we'll do this using sed, and this is a little bit out of the scope of the workshop, but basically this is um, a regular expression, which is basically saying, okay, the first 50 characters, yeah, just delete them. Just you don't need them anymore. Um, yeah, and like I said, the output. So the output of grep is going to go into this, into deleting the first 50 characters. So if I run this, now we really only get the end of each line, right? Now, I already said all the different commands that you can use. Unique was one of them. If we do man unique, it filters out repeated lines. Um, Now, one kind of quirk about repeat or unique is that the unique lines have to be right next to each other. So as an example, it would remove these three Alex Fabricio's join the game lines, but it won't remove this one because they have to be right next to each other. Now, luckily, this is really easy to do or really easy to fix because we have piping. So what we can do is before we throw it through sort or through unique, we can actually sort it. So we sort it. Now we actually have all the times but sorted, right? And now this output again, we pipe this into unique, um, and especially unique tag C, which basically counts the amount of times this each line is repeated. So we do that. Bam! You can see that this one appears 48 times. This one appears 87. This one only appears twice. Now, finally, we can actually sort this because we want to get the person who has been the most. So if we sort this, we actually need to use the BGR, so bigger. If we don't do that, actually, it'll go from smallest to biggest, which may be what you want. But no, we want the biggest to smallest. So tag BGR, bam. Just one line of a command, we're able to get a list of the people who have joined the server and how many times they have. Yeah, and this, like, again, the more you do this, the more familiar you get with it. So this took me a little bit, took me like a couple minutes. Um, but once you know what you're doing, it gets easier over time. Yeah, and now you have one line. If you ever have Minecraft logs to be able to count the amount of people or the amount of times someone has joined. I'll go ahead and actually drop that in the group chat or in the chat. Right. And here I have the steps of what we just went through. Again, use grep to find every line with the word joined. Use sed to remove the first 50 characters. Use sort to sort it in alphabetical order. Then use unique to count the amount of unique lines. And finally, use sort again to see the amount of times that a player has joined the server. Now that was a lot. I know I like rambled a lot. Um, definitely, definitely use these skills in CCDC. Um, like one of the main tasks that, or one of the tasks that we had was basically exactly this. We had to get how many times someone had joined a specific server. Um, and I used, like, I basically used this same thing. I grabbed for joining, and I used set and sort and unique. Um, so yeah, it definitely helped me. It definitely helped us in CCDC. Yeah, good question. All right, we'll go into security. Right. So very basic general security. Um, for Linux, there are different users on the system. Now, user, according to Linux, is an entity that can manipulate files and perform several other operations. That's a very fancy way of saying just users, you know. Um, you would use users to basically create a hierarchy of control access. So, for example, you don't want someone else that uses your computer to be able to touch your files. Um, so you would have some files being owned by someone for one user, and other files owned by another one, and you would not allow access of the files of one to the other person. Very self-explanatory. Um, who am I is a command that shows you which user is running the command. I already showed you that previously, but I'll go ahead and show you that again. Um, if I run who am I, if I spell it correctly, it says Nelson Torres. That is the user that I'm currently logged uh, into this computer with. Again, if you have a Mac, you can do that again. Probably will be some combination of your name and your last name. If you're on Linux, um, you make your user when you first create your computer, set up the system. Now, a root user. Root is actually a very specific user. It's a very special user. It's the username that by default has access to all commands. And I don't know what I meant by that on a Linux system. Um, so basically, or every file, basically. Let me go ahead and fix that. Sorry about that. Yeah, so the root user has the ability to see everyone's files and everyone's folders, and is able to run every application on your computer. Obviously, root users is very. You have to be very careful with using the root user. Usually, you're not logged in as the root user, but you have to use the root user to, for example, install certain programs. So, for example, if I were to install a program on my Mac, it'll tell me, "Hey, use your fingerprint to install this application," because you don't want any random person to be able to install applications. In the background, what the Mac does is actually um, log in temporarily as the root user and install that program for me. And how does it do that? How do you go from one user to another? Or specifically, how do you go from like Nelson Torres to root, which is what we want to do? And to do that, we actually use sudo. Sudo is a command that gives non-root users the ability to run commands as administrators. So sudo, you got to be very careful with this, because every command that you run after you run sudo is being run as the root user. So as an example, I'll go ahead and do sudo tac-i, which basically just logs me in, or I try to log in as root. Tells me what's the password. I'll go ahead and type the password for my computer. And bam, I am now root. And the way I would know this is, again, who am I? Tells you that I am root now. Now, as root, I can do a lot of things here. And this is really dangerous, right? I can literally wipe my whole computer if I really wanted to with the command I showed earlier. But um, obviously, I don't want to do that. I'll go ahead and X that out of this, so I don't I don't feel tempted to do anything malicious. But a lot of the times when you're running a command, if you're like following someone's tutorial, they'll be like, "Oh, just run sudo." Um, if you're on Linux, you'll do sudo app install. I don't know, OpenSSH server, right? And then it asks you for a password, and you do the password. And a lot of people don't know what they're doing. Um, they just see a command, they run it, ask for a password, they type it. Um, you got to be really careful with this because if you do sudo and you run a command that you don't want to run, like again, delete everything in my computer, um, it'll be really bad. Like someone malicious can give you a really bad command to run. So just be aware of that. Here's a little meme for XKCD fans. Make me a sandwich. What? Make it yourself? No, sudo. Make me a sandwich. Okay. Basically, sudo tells you to just do it, and you do it. You have access to it now. Now, as developers, I just gave you a lot of different commands, but as developers, these are, I think, some really important commands that you should know. Um, you probably know a couple of them if you have used the Linux command line before, but these are what I think is most important. Um, First one being curl. Curl basically transfers data from and to a server. So usually it's used to download files. So if you want to download like an ISO to a server, you would usually use curl for this. Git, another command. You have probably used Git or GitHub before. Git is the command line version of Git, which is like the original one. Helps keep track of code. Very important, very useful to know. Highly recommend if you're a developer to at least follow like a 30-minute tutorial on how to use Git. Apt, it helps handle packages on your Linux system. This also depends on the distribution. So if you're using Ubuntu or Debian, which are very common ones, it's apt. But if you're using something else like CentOS, you would use Yum, or Arch Linux, you would use Pacman. Basically, if you installed Linux, know what package manager your system uses. Yeah. Next up, Chmod controls who has access to files. So like I was saying previously, different users have different access to different files. So you definitely want to know who has access to your file. One really scary command that people can run, say for example, this main.c, this file, for some reason had my password. Someone malicious could do something like this. Right? And without me knowing, basically what this does is it changes the permissions so that anyone in this computer has access to that file. And if you don't know that, if you're just running commands and installing things and they tell you, hey, just chmod 777 this file, without you knowing, you're giving access to everyone that uses your computer or that server access to that specific file. So you got to be careful with that. You should know about that. PS gives you info on running processes. So basically, if a program is running on your computer, PS tells you if it's running. I'll go ahead and just show a quick demo of that. I am running a lot of things on my computer. But if, for example, if I were to run ship, right? So right now, this is a program that's running on my computer, ship. If I go to the other terminal and I do ps aux, right? it's gonna give me a bunch of information. But again, like we have learned already, you can actually put this data into somewhere else. So grep will literally just grep for a specific word. We'll just look for the word ship, and we can see that there is a process right here that's running ship, this one, and we can see that it's running. If I were to run like 5 ships, it'll show up 5 different times. Now, the second I quit this and I run this again, that one at the bottom doesn't exist anymore. The only program that exists that has ship in it is actually our grep for ship. So again, this is how Linux, you're able to use different commands like combined to be able to be like really effective with what you're doing. Um, Finally, GCC. If you have taken an Intro to C class, I hope you know what GCC is. It compiles C programs, so it's really important to know what compiler or what command the language that you're writing in is using in the background. Even if you use an IDE, it's still really important to know. Here for ship, for example, it's actually a C program. So if I were to do GCC main.c, it'll take a bit because it has to compile. But and then I do ls. Here we see the actual program a.out. It compiled it for us. And like I said, if you use an IDE, the IDE actually does this in the background, and you don't know. But it's really important for you to know what your IDE is actually doing in the background. Then we can play Battleship. Yep. And there's a bunch of different other commands that I would recommend, but these are like top 10 commands that I would recommend. Finally, we'll end this off with how not to install programs. Homebrew, if anyone uses Mac, basically it's the package manager of Mac that you're able to install, and it's very good. It's very good program. However, when you install it, it basically just gives you a command to run. Just one very large command to run. Let me actually just pull it up on the side. So you can see. It just says, okay, install Homebrew, just run this command. Right? And it's very good, right? Because it's just, you don't have to think about it. You just run that command. God knows what that command does, right? It's great. No, that's not good. You, as a user, you might not know what this command actually does. So that's why it's important to know, what commands actually do. Here I say there's actually a fun way. So this actually uses curl. So it curls a very specific file. So that actually open that file. It's just a script on how to install it. So basically it downloads that file into your computer and it runs it. Now we know that this file is good. It's been checked a bunch of times, but someone malicious can, for example, detect whether you're using curl or not. And if you're piping into bash, which is what this is doing, it can change the script that it's actually downloading and then change it to something malicious. So that's really bad, right? It might be, it'll be really bad. So what I recommend is instead of doing it in one command, you do it in 3 steps. You curl the script like it tells you to, but then you save it to a file. Then you read the contents of that script, make sure everything there is good, like just skim through it at the very least. Know that it's not a bad thing. And then you can run it using bin bash. I won't run it, but I'll actually just show you how to do that real quick. Basically, the script, we do It's the same command. It's the same curl command right here, except we're not running it immediately. We just curl and we use the redirect to redirect it to a file. Call it a script. Now we're able to actually open up the script file, and here is a bash script that it does whatever it does, and we can read through it, right? Now this is really long, so you probably won't, but just make sure there's nothing like obviously malicious. And then finally, you would run this using bin bash, but I'm not going to do that because I already have Homebrew installed. But yeah, that's really it as far as the presentations goes. However, I'll stay around for the next 10 minutes if you have any questions or concerns. Literally any question regarding Linux, I'll try my best to answer. I don't know why the logo is a penguin. You might want to look that up. All right, so Caleb, I'm interested in joining a C3 team. Where should I get started? So joining it, so if you're a UCF student, which I'm assuming you are, you would go to the Hack UCF club, Hack at UCF. Let me go ahead and actually get you the website. That's a great way to get started if you don't know much about about hacking or just cybersecurity in general. If you think you know enough about cybersecurity that you just want to join the team, there are kind of tryouts. Talk to Dr. Niederust. His name is Tom. I'll go ahead and send you I'll give you his email. Basically, he is the head organizer of everything. He's the one that picks each person and who goes to the competitions, because we only send our top 8 students or the top 8 people in the club, plus 4 alternatives if someone gets sick or something like that. Just give me a second. I'll go ahead and give you his email. I believe it's this one. But if by getting started you mean like how do you actually prepare, like before you go to the practices, actually I would recommend joining the Hack UCF Discord. They would probably give a way better answer than what I can in the next like couple minutes. We have really very talented members at Hack UCF, way more talented than me. And just going to the meetings and being in the club, you learn so much just from being at the club. So that's what I would recommend. You join the Hack UCF club. It's really difficult to say how exactly you would go step by step. It also depends on what you're good at. It also depends what you're interested in. As an example, I had somewhat used Linux before I joined the CCDC team, and on the team, like going to the meetings and things like that, I learned so much. Like all of this, I learned it from the meetings because I was actually like pretty weak on my Linux. We also have like spots for Windows, and we have spots for networking and business, but but so it depends on what you like. But again, like I said, join Hack UCF. That really is the best way to learn. Alan says, way off topic, why is it that Linux is preferred in areas like data centers? That's a great question. There's probably a lot of different reasons. Linux, I mean, at least in compared to like Windows, for example, is a lot more scalable. It's a lot more usable. I'll say that. As far as like the system administrator side of it goes, it's also cheaper. Most of the times, you're not paying for the OS, for the operating system. Usually, it's free. Windows, you have to pay. But a lot of times, programs are just built to run on Linux. Git, for example, even though it runs on Windows, it was originally written to run on Linux. Same thing with uh, things that host like web servers, for example. A lot of them are written first on Linux, and then they have something for Windows. Usually it's the opposite, right? Usually applications like games, they make a Windows version, and then maybe they have a Linux. But for software, for like server softwares, it's usually the opposite. Yeah. Yep, that's another really good one. Linux uses a lot less resources in general. Um, and that's like obviously really important if you're running thousands of servers at the same time. That's a good one. Thank you, Joseph. Yep. Any more questions? Yep. Have an enjoyable night hacks, everyone. Thank you so much for coming.